So first, start with an example. Since we are having the data visualization course, let's start with some data visualizations. So first, we have a data set here. So actually, we have 4 data sets. So 1, 2, 3, 4. And each of the data set, there are one X variable and another Y variable. And this happens for all of these 4 data sets. So under each of the X value variables, there are different value that are assigned for the X and different value that are assigned for Y. If I ask you if, so for instance, I ask you if all these data sets are the same or not, and what can you conclude from the data set? So first thing you may think about is to calculate the descriptive statistics of all the data set here. So here, let's look at this data with statistical analysis. So we calculate the mean and the variance. So the mean is calculated by sum up all the value of each variable and divide by the number of observations here. In this case, we have 3, 4, 5, 6, 7, 8, 9, 10, 11. So we will sum all this number up and divide by 11. Then we have 9. The next descriptive statistics we conducted is to calculate the variance. So the variance tells you how far away each of the data points are from your mean. So if you have a more spread out data set, or on the other hand, most of the data set most of the data points are close to the mean of the variable. So in this case, we have 9 for all the x's, and all the y's have a mean at 7.5, and all the variance are the same. The variance are the same for the y's. So in this case, you may conclude that we have 4 identical data sets just based on the statistics here, based on the mean and variance. However, if this is true, is this really happening or not? Let's visualize the 4 data sets. So we have 4 scatter plots here. The scatter plot, so this is called scatter plot. So scatter plot is a plot that you plot each of the data points of the observation here. So for instance, here our axis is X and our vertical axis is Y. So these data points represent our X equal to 4, right? Yeah, and the Y equals to 4. So we plot all these observations in the same plot within the first data set. So now you can easily see that we have 4 different data sets, right? So we reach a different conclusions from our descriptive statistics. So first data set, all the data points are more like spread out, versus the third one, all of the data points are close to our trend. So the red line represents the trend of your data set. This one is spread out, and also there is a curve. And the last data set means that you can see it's on a straight line, means that all of the data points has the same X value. So again, we have a different story now. Second, why data visualization is important? Because data visualization is easier to remember. There is an effect called a picture superiority effect in the field of psychology, which means pictures are retained at much higher rates than words. So if you remember, if you see here, this one is from a researcher in the psychology. So he did a research saying that he test how much information people remember after 3 days. They saw a message. So on the left is a message that only contain text, and he found out people only remember 10% of the messages after 3 days, versus on the right, he showed a text plus a picture to the participants of the study. Most of people retain 65% of the message. So in that case, when you present text plus the image, that is just help the readers to memorize what you presented to them. The next point is visualization reduces the time to insight. So in that case, sometimes you just don't have the time to do the math calculations to calculate what's the mean, what's the variance, what's the standard deviation. And on the other hand, you can just simply plot, use the software to provide you the data visualization and see the big picture of your data set. So in this case, the data visualization help you to identify the trend without the descriptive statistics. So save some time to get you the big idea. This is super important when you have a big data set. If you ever heard of big data, so big data can be characterized with something called 3V. First is the volume. So the volume represents how much data you have. So for instance, zettabytes data will be created by 2021. So that represents the amount of data. Our second V is the velocity. So the velocity means how fast the data is coming in. And for instance, 900 million photos were uploaded by Facebook users each day. So whenever we deal with social media data, it's just so surprising. You can see how much data can be transmitted and how fast they can be transmitted. Then the last aspect is the variety. Variety. So the variety means data can be very different from one to another. For instance, in just email, in the email message, you can have different tags. You can write different tags. You can send an email to different destinations at a different timestamp. And also you can attach different attachment to the email. And also there are different types of formats of the data. You can have text, you can have images, you can have videos, audios. Those are all data comes with different format. So again, since we have big data, we have too much data going on, we don't have to know the precise details of each single data points. What we sometimes just need to know the overall trend of your data. So in that case, data visualization will be helpful. So for instance, here we have a data set, we have a table contains sales by region. So if I ask you how fast, how quickly can you identify the top 5 best sales among all the regions? It's just so hard to tell. There are some will stand out right away, like these start with 6. However, it just takes so much time to process all these numbers. Versus if you add some data visualizations to the same table, it will make things easier for the readers. So you will mark all these top 3 cells with a blue color. That will save a lot of time, especially if you have a big table. Okay, so next point is data visualization correct misconceptions and perceptions, because people's perceptions influences their decision making, but sometimes their perception is wrong. So for instance, today it's so sunny outside, and I will get the perception saying the temperature will be high. So I decide just to wear a t-shirt. However, the perception is wrong and lead to the wrong decision until I read the reports from the weather department. Then I can see that the number, I can see the report, I can see the data visualization they showed. Then I know that I should bring a jacket with you. So in that case, the data visualization corrects my mistakes, corrects my wrong decisions based on the wrong perception. Okay, so next, the history of visualization. Let's see, the first visualizations were maps. So here we have example, is a Babylonia map from 600 BC. So people just scratched on rocks, and this rock will function as both hunting guides and directions to the spirit world. And second, first grids used for numbers. So this is something called Cartesian coding systems, and this was created in the 1700th century by French mathematicians, and this is also an early version of scatter plot, which we will discuss later. We will learn how to do a scatter plot in our class. Modern days, we will have different line chart. So this is an example from 1821. So it's a records of wheat price from weekly to weekly. That means we have a time series data, and from the year span from like 1700 to 1780. This was created by a Scottish statistician called William Playfair. And he was also the father of statistical graphics, which include the line chart, bar chart, and pie chart. So while modern day invention has had the most influence of data visualization. So back in the old time, people have to draw their visualizations by hand. But with the invention of computer, they can rely on the softwares, which is easier and quicker to get access to the data visualization. But since it's so easy to get a visualization, people just rely on the softwares too much sometimes. They just provide the data visualizations without any input, without any insights, without any interpretations. So that's something we have to think about when every time we create some data visualization. So the next objectives, what's the definition of visualization? First, we will read definitions from 3 parties. First, Gartner. Gartner is global consulting firm that they provide suggestions to different businesses. Second is Edward Tufte. So Tufte is American statistician from Yale University, and he has written several books on data visualizations, and also he hold online courses on data visualizations, which you can Google. The last person is the author of our textbook, and he is not a professor per se, but he thinks himself as an educator to promote data visualizations. So that's why his book is so easy to read, and we chose his book as our textbook. First definition from Gartner. Visualization is the illustration of information objects and their relationships on a display. Strategic visualization graphically illustrates the strength of relationships by proximity of objects on the display. So you can see from this definition that the visualization is based on the relationship of information systems, of the information. So you can see that relationship is the key here. Also, speaking of relationship, if you have, for example, if you have two variables, X and Y, you can assess and you can make conclusions based on their relationships, right? If the data looks like this, if they have a trend look like this, you can say that they have a positive relationship, meaning that when the value of X increases, the value of Y will increases as well. So for instance, you can see that the more education you get, the more years of education you have, the more money you will make in the future. So that's a positive relationship versus the negative relationship look like this. That means when the value of X decreases, the value of Y will decrease. So when X increases, Y will decrease. One example for that is that when the more hours you exercise, you will lose weight. So the weight number of your body will decrease. And also like the more hours you study every day means the less hours of sleeping you will get each day. Next definition from Tufte's. So data visualization is the process of presenting information through some visible means. Its goal is to make it easier to see patterns and determine means for complex data sets. So this definition emphasizes on seeing patterns and finding the means from a set of data. So you want to see the big pictures of the patterns. The patterns can be also seen as the relationship happening within your data set. The last definition is from Phil. His definition has 3 parts. So the definition is that data visualization is a collection of methods that use visual representations to explore, make sense of, and communicate quantitative data to explore, make sense of, and communicate. So that's the 3 parts. And we will use these definitions since we use Phil's textbook. And you can see that the 3 definitions are very similar with each other. It just has different emphasis. So next part is the comparison between tables and graphs. So tables has different rows, tables has different columns, and you have numbers between different cells. And the tables tends to rely on humans' verbal systems, which means we read the numbers and then we compare the numbers between each of the cells, between each of the rows, between each of the columns. And to use a table when we want to look up individual values, when we want to compare individual values, and if we want to use the values like precisely. So we have to use table. Versus graphs. Graphs are like bar charts, line chart, pie chart, and this type of chart tends to rely on human visual systems. So we only have to see it as a big picture, as a picture that provides the big trend, the big overall relationship of the data set. So again, when we need to use a chart, we want to show overall shape of values, show relationship among multiple values using patterns and trend. In that case, we will use graphs. Okay. So is table visualization? Personally, I do think table is a visualization, but there are debates between different people. That some people argue that table is not a visualization because it's not like an image or graphs. And I believe tables is a visualizations because you can do lots of different modifications to the table, like you can add colors, you can bold your text messages, you can compare numbers between each of the cells. You can just do so much about one table. The last objective is to discuss the purpose of visualizations. So Phil's definition is saying that data visualization provides the user with important, meaningful, and useful insights. So it can be broken down into 4 different chunks. First, analyzing. Analyzing means to discover insights from your data set. So you can get overall information, for instance, like if you have enough data for your analysis, or if you have to create more data visualization in order to reach certain decisions, to reach certain conclusions, or if you have to do some math to do the descriptive statistics. The second part is the communication part. So if you are able to pass along the message to your users or not. So for instance, some questions you will ask during this process is, what is the best way to present this data set to the audience? Should we use a table or should we use a chart? And if you want to use a chart, should we use bar chart, should we use line chart, or should we use pie chart? So these are some of the concepts that we will also discuss in our course. Third part is the monitoring. So you will keep track of the data about performance, such as what has been changed in the past. And you want to check for the errors if you notice some like irregular data trend happening in your new data set. Then the last part is the planning. What will happen in the future? So you will run a predictive analysis from your data set, such as what do I need to know about this year so that I can prepare for the future. So these are the 4 purposes of the visualization. Okay, so that's everything for our module 1.